Hello everyone, my name is Ki Wong, and this is my BMI224 final project. Today I'm going to talk about baclofen and the gene GABBR1. Baclofen is a gamma-aminobutyric acid derivative clinically used as a skeletal muscle relaxant. It is for the alleviation of signs and symptoms of spasticity resulting from multiple sclerosis, particularly for the relief of flexor spasms and concomitant pain, clonus, and muscular rigidity. Baclofen stimulates GABA B receptors, leading to decreased frequency and amplitude of muscle spasms. Its LD50 is 45 mg per kilogram for male mice and 78 mg per kilogram for male rat. Half-life is about 2.5 to 4 hours. Baclofen is a direct agonist at GABA B receptors. It is capable of inhibiting both monosynaptic and polysynaptic reflexes at the spinal level, possibly by hyperpolarization of afferent terminals, although actions at supraspinal sites may also occur and contribute to its clinical effect. GBBL1 is involved in several pathways. The main ones are inwardly rectifying potassium channels, activation of GABA B receptors, transmission across chemical synapses, and signaling by GPCR. It is a metabotropic G-protein coupled receptor responsible for slow, prolonged inhibitory effects of GABA alongside ionotropic GABA A and GABA C receptors. They exist as heterodimers of GABA B1 and GABA B2 subunits, and the presence of both subunits is required for receptor function. Baclofen has pre- and post-synaptic effects. Presynaptic effects comprise the reduction of the release of excitatory and inhibitory transmitters, whereas postsynaptic GABA-BR decrease neuronal excitability. It has 5 alternative splice variants, 68 SNPs, of which 34 are validated according to dbSNP. There's no known variation across different populations due to lack of association studies. Isoform 1E may be to regulate the availability of functional GABA-BR1, GABA-BR2 heterodimers by competing for GABA-BR2 dimerization. There are possible associations of 3' missense polymorphisms in OSAS, and is also a possible association with temporal lobe epilepsy. Due to the difficulty in developing effective treatments, many neurological disorders' underlying causes were still poorly understood, since brain science is still evolving. Therefore, there is little or no pharmacogenomic data on baclofen and GABBR1. However, there are pharmacological potential for autism as a repurposing drug. 1 in 50 children aged 6 to 17 have been found to have autism or a related disorder. That's a 72% increase since 2007. And currently there's no drug approved to treat the core symptoms of the disorders. As recently as December of 2012, Seaside Therapeutics, a entity in Spain, has shown STX209, a form of baclofen, acts upstream from mGlu5 receptor signaling and is thought to augment inhibitory neurotransmission, show potential for clinically meaningful improvements in social function. The drug is still in phase 2 clinical study. So we know that baclofen targets both GABBR1 and GRM5, so investigation can be focused on a drug target network, and we can also investigate drug target using side effect similarity and ligand chemistry. That's the approach that we learn in the pharmacogenomics. Other autism drugs in the pipeline are from Novartis, which is in phase 3, Another drug is from Roche, and it is in phase 2. Thank you for watching.